Good morning to one and all. Today's topic is differential calculus and the subtopic is maxima and minima of a function of two variables. First of all, I am going to explain the definition of maxima and minima of a function of two variables. A function f of x comma y is said to have a maximum value at a comma b if there exists a point in the neighborhood of the point a comma b, say a plus h comma b plus k, such that f of a comma b greater than f of a plus h comma b plus k. Similarly, if f of a comma b less than f of a plus h comma b plus k, then f of x comma y is said to have a minimum value at a comma b. Once again, observe f of x comma y is the given function. This function is said to have a maximum value at a comma b if there exists a neighborhood of a comma b. Consider a neighborhood of a comma b. In this neighborhood, a plus h comma b plus k is a point. If f of a comma b greater than f of a plus h comma b plus k, then we say that f of x comma y is having maximum value at a comma b. If f of a comma b less than f of a plus h comma b plus k, then we say that f of x comma y is having minimum value at a comma b. F of a comma b is said to be an extreme value of f of x comma y if it is a maximum value or a minimum value. Once again, f of a comma b is said to be an extremum value of f of x comma y if it is a maximum value or a minimum value. Now we are going to see when the function is having maximum and minimum values. Necessary conditions for maxima or minima. Statement: the necessary conditions for f of x comma y to have an extremum. An extremum means it is maximum or minimum at a comma b are that dou f by dou x equal to 0 and dou f by dou y equal to 0 at the point a comma b. The given function f of x comma y is having maximum value f of a comma b if ac minus b square greater than 0 and a less than 0. That means f of a comma b is maximum value if ac minus b square greater than 0 and a less than 0. F of a comma b is a minimum value of f of x comma y if ac minus b square greater than 0 and a greater than 0. Observe, in these two conditions, the value of ac minus b square is greater than 0. Whenever a less than 0, then f of a comma b is maximum. Whenever a greater than 0, then f of a comma b is a minimum value of f of x comma y. If ac minus b square less than 0, then we say that f of a comma b is not an extremum value. That is, f of x comma y is neither maximum nor minimum at the point a comma b. and the point is called saddle point, where capital A means fxx, capital B means fxy, capital C means fyy. Now we are going to find critical points. How to find critical points? Observe, find first order partial derivative with respect to x, equate that to 0. Again find out fy, equate that equal to 0. From these two equations, we are going to find out critical points. That is, by solving these 2 points, we are going to get critical points. Example 1. Find the extreme values of the function f of x comma y equal to x cubed plus y cubed minus 3x minus 12y plus 20. Now we are going to find out the extreme values of the function, that is maximum value and minimum value of the function f of x comma y equal to x cubed plus y cubed minus 3x minus 12y plus 20. Solution. The given function is f of x comma y equal to x cubed plus y cubed minus 3x minus 12y plus 20. First of all, I am going to find out partial differentiation of f with respect to x and equate that to 0. Then we are going to get equation 1. This is the given equation. Fx value means partial differentiation of f with respect to x. If we are doing with respect to x, y is constant. X cubed differentiation is 3x square plus y cubed is constant, that's why differentiation is 0. Minus 3 for x 1. This totally becomes constant, that's why constant differentiation is 0. So finally we are going to get fx value as 3x square minus 3. Now I am going to equate this value to 0. Observe, here 3 is common. Take 3 common, then we are going to get 3 into x square minus 1 equal to 0. If the product equal to 0, either first term equal to 0 or second term equal to 0. Here the first term 3 is not equal to 0, that's why the value of x square minus 1 equal to 0. It implies x square equal to 1, implies x equal to plus or minus root 1. Plus or root 1 means 1 only, that's why the value of x is plus or minus 1. We get this one by considering fx value equal to 0. Now we are going to consider fy equal to 0. For that we want to first find out fy. Fy means partial differentiation of f with respect to y. Now consider fy equal to 0. Find out fy. We are doing with respect to y, that's why x is constant. Fy means dou by dou y of f. So x constant, x cubed constant, constant term differentiation is 0. Y square is there, y square differentiation is 3y square. Minus 3x is constant, constant differentiation is 0. Minus 12y differentiation is minus 12 is constant, for y is 1. 20 is there, 20 differentiation is 0 because it is a constant. Now finally the value of fy is 3y square minus 12. Now equate this value with 0. Then we are going to get y values. Take 3 common, y square minus 4 equal to 0. Again 3 not equal to 0, that's why y square minus 4 equal to 0. Next Observe, y square equal to 4 implies y equal to plus or minus root 4. We know the value of root 4, that is root 2. 2 only, that is 2. Therefore, by considering fx equal to 0, we get x equal to plus or minus 1. By considering fy equal to 0, we get y equal to plus or minus 2. By using these values, we are going to writing critical points. First observe, keep plus 1 common. So observe plus 1, here plus 2. Next 1, next here we take minus 2. Next here minus 1, here plus 2. Next minus 1, minus 2. So from these x and y values, we are going to get 4 critical points. Those are mentioned here. Now I am going to find out A, B, C values. A means f double x. That means dou by dou x of fx. So we want to do partial differentiation of fx with respect to x. Substitute fx value. 3 is a constant. X square differentiation is 2x. Minus 3 is constant. Constant differentiation is 0. So a value is 6x. Now find out b value, that is fxy. Fxy means partial differentiation of fx with respect to y. Substitute fx value, that is 3x square minus 3. Observe, here the partial differentiation with respect to y. Here no y terms. That's why this is totally constant. Constant differentiation is 0. That means b value is 0. Next to find out c, that is fyy. Fyy means dou by dou y of fy. So substitute fy value, that is 3y square minus 12. 3 is a constant. Y square differentiation is 2y. Minus 12 is constant. Constant differentiation is 0. That's why we are going to get c value as 6y. Now find out AC minus b square value. A value is 6x. C value is 6y. B square is 0 square means 0 only. 6 6 are 36 xy. AC minus b square value is 36 into xy. Now I am going to find out AC minus b square value at each of the critical points. If I am considering the critical point minus 1, 2, then AC minus b square value is 36 into minus 1 into 2. That is minus 72. Minus 72 is less than 0. A value is 6x. That means A equal to 6 into minus 1. That is minus 6 is less than 0. So first of all I am writing all values. After that we will discuss. Minus 1, 2. At this critical point, AC minus b square value is 36 into minus 1 into minus 2. So minus into minus plus 72. 72 is greater than 0. A equal to 6x implies A equal to 6 into minus 1, that is minus 6 less than 0. Minus 6 less than 0. At the point 1, 2, AC minus b square is 36 into 1 into 2. That is 72. That is greater than 0. A value is 6x. 6 into 1 6 greater than 0. At the point 1 comma minus 2, AC minus B square equal to 36 into 1 into minus 2, that is minus 72, less than 0. A value is 6 into 1, that is 6 greater than 0. Observe these values what we are going to get. Conclusion. At the point 1 comma 2, AC minus B square value is greater than 0, A greater than 0. Therefore, f of x comma y has a minimum value at 1 comma 2 and the minimum value of f of x comma y is calculated as follows. F of x comma y has a minimum value at 1 comma 2. Substitute 1 comma 2 in fx comma y, then 1 cube 1, 2 cube is 8, minus 3 into 1 is 3, minus 24 plus 20. Simplifying, observe, here the positive quantity is 29, negative quantity is 27, so we are going to get 2. That means 2 is the minimum value of f of x comma y at the point 1 comma 2. Next observation, at minus 1 comma minus 2, AC minus B square greater than 0 and A less than 0. Whenever A less than 0, f of x comma y is having maximum value at that point. And the maximum value of f of x comma y is, substitute minus 1 comma 2 in the place of x and y. Minus 1 whole cube is minus 1, minus 2 whole cube is minus 8, minus 3 into minus 1 is plus 3, minus 12 into minus 2 is minus 20 plus 24, minus 20 as it is. Here the negative quantity is minus plus 20, this one. Negative quantity is minus 9. Positive quantity is 47. So we are going to get 38. This is the minimum value. This is the maximum value. What about remaining 2 points means? The remaining 2 points 1 comma minus 2 and minus 1 comma 2 at which AC minus B square value less than 0. Whenever AC minus B square value less than 0, at those points f of x comma y is having neither maximum nor minimum. Those 2 points are called saddle points. Second question, example 2. Find the extreme value of the function f of x comma y equal to 2 times of x minus y whole square minus x power 4 minus y power 4. Observe, here also we want to find out minimum value and maximum value. The given function is f of x comma y equal to 2 into x minus y whole square minus x power 4 minus y power 4. Find out fx and equate that one to 0. Fx means partial differentiation of f with respect to x. Here we are doing partial differentiation with respect to x. That's why y is a constant. 2 is constant. First I am going to use power formula. 2 into x minus y power 2 minus 1. N into x power n minus 1. Here 1 x differentiation is 1, y differentiation is 0. Because we are doing with respect to x. Minus x power 4 differentiation is 4x cube. Y power 4 differentiation is 0 because y is a constant. Now we are doing simplification. 2 into 2 is 4. x minus y power 1 minus 4x cube. Now I am going to equate this value to 0. That is 4 into x minus y minus 4x cube equal to 0. Observe 4 is common. X minus y minus x cube equal to 0. So product equal to 0 means either first term equal to 0 or second term equal to 0. Here the first term is 4. 4 is not equal to 0. That's why x minus y minus x cube equal to 0. Take this negative sign. So again rewrite the given equation. That means x minus y minus x cube equal to 0. Consider this as equation 1. Next, find out Fy. Fy means dou by dou y of f. So, dou by dou y of substitute f value. Here 2 is a constant. Again use the same power formula. N into x power n minus 1. For x 0. For y minus 1. Minus 0. Why 0 means we are doing with respect to y. 4 into y cube. Simplify. Minus 4 x minus y minus 4 y cube. This is the value of Fy. Now, equate this Fy to 0. Minus 4 x minus y minus 4 y cube equal to 0. Take minus 4 common. Then x minus y plus y cube equal to 0. Implies minus 4 not equal to 0. That's why x minus y plus y cube equal to 0. Consider this as equation 2. Now we have two equations. That is equation 1 and equation 2. This is equation 1. This is equation 2. Subtract. Cancel. Cancel. Next we are going to get minus x cube minus y cube equal to 0. Multiply with minus 1. X cubed plus y cubed equal to 0. X cubed equal to minus y cube. Next x cube equal to minus outside y cube power 1 by 3. 3 get cancelled. Then x equal to minus y. Otherwise here you can write 3 means take whole power 1 by 3. 3 get cancelled. Therefore x equal to minus y. X equal to minus y we are going to get after solving these two equations. Now put x equal to minus y in equation 2. That means we are going to get minus y plus y cube equal to 0. Implies minus 2y plus y cube equal to 0. Implies take y common. Minus 2 plus y square equal to 0. Implies y equal to 0. Y square minus 2 equal to 0. Y equal to 0, comma, y square equal to positive 2. Implies y equal to plus or minus root 2. Now we have 3 y values. One is y equal to 0. Second one is y equal to plus 2. Third one is y equal to minus 2. Now we want to find out x values. X equal to minus y we have. That's why if y equal to 0, x equal to 0. If y equal to plus root 2, x equal to minus root 2. Substitute y value here. Then we are going to get x equal to minus root 2. If y equal to minus root 2, then x equal to minus of minus means plus root 2. So we have three critical points. Those are 0, 0. First I am writing x value. Next I am writing y value. Minus root 2, root 2. Next root 2, minus root 2. These are the critical points. Observe critical points. Next we want to find out a, b, c values. A equal to fxx. So observe dou by dou x of fx. So 4 is a constant, for x 1, for y 0, minus 12x square. Y means x cubed differentiation is 3x square. 4 3s are 12x square. 4 minus 12x square. B equal to fxy. That means dou by dou x of dou by dou y of fx. So fx here 4 is a constant. For x 0 because we are doing with respect to y. For y minus 1. This is constant, that's why 0. So b value is minus 4. Now I am going to find out c value, that is fyy. That means dou by dou y of fy, which is equal to minus 4 constant. For x 0, for y minus has this, for y 1 minus 12y square, because minus 4 into 3y square. Y cubed differentiation is 3y square. That's why minus 12y square. So c value is positive 4 minus 12y square. Now I have a value, b value, c value. That's why I am going to find out ac minus b square. Observe, a means 4 minus 12x square. C means 4 minus 12y square. B square means minus 4 whole square, that is 16. Here observe 4 is common. Take 4 common. Here also 4 is common. Therefore 4 4s are 16. 1 minus 3x square, 1 minus 3y square minus 16. Next, I am going to find out AC minus B square value at these critical points. At origin, AC minus B square, that is, substitute x equal to 0, y equal to 0. If x 0, y 0, then we are going to get 16 into 1 minus 0 is 1, 1 minus 0 is 1, 1 into 1 is 1, minus 16, so 0. Next a value is 4 minus 12 into 0 square. 0 square is 0, 4 minus 0 is 4. This is greater than 0. Next, minus root 2 comma root 2. At this point, AC minus B square value is 16 into 1 minus 3 times of minus root 2 whole square. Observe, x square means minus root 2 whole square. Minus square is plus, root 2 square is 2. Similarly, 1 minus 3 into 2 minus 16. So 16, this is 6. 1 minus 6 is minus 5 minus 16. So minus into minus plus, 16 5s are 80, 80 5s are 400. Minus 16. So we are going to get 384, that is greater than 0. A equal to 4 into minus 12. X square means same thing, minus root 2 whole square, that is 2. So 4 minus 24, that is minus 20 less than 0. So observe, AC minus B square value is 384 greater than 0. A value is minus 20, that is less than 0. Conclusion. Since AC minus B square greater than 0 and A less than 0 at both points minus root 2 comma root 2 and root 2 comma minus root 2. Therefore, f of x comma y is maximum at both these points, and the maximum value of f of x comma y is, substitute either one of these points in the given f, that means 2 into minus root 2 whole square minus root 2 whole power 4 minus root 2 whole power 4. Replace x with minus root 2, y with root 2, or x with root 2, y with minus root 2. So observe, minus root 2 is minus 2 root 2 whole square. Here you can observe minus power 4 means multiplication of minus 4 times, that is plus only. So plus root 2 whole power 4, that means root 2 into root 2 into root 2 into root 2. So this is 2, this is 2. 2 2s are 4. Similarly, root 2 power 4 is 4. Here we have minus sign, minus asterisk, minus asterisk. Here we have minus 2 root 2 into minus 2 root 2. Minus into minus, plus 2 2s are 4. Root 2 into root 2 is 2. So 8. So 2 into 8 minus 8. That means 16 minus 8, 8. This is the maximum value of f at these 2 points. I am substituting second point also. At that time also I am getting 8 only. At the origin, AC minus B square is 0 and A greater than 0. Here AC minus B square equal to 0. That's why we can't say anything about the nature of the function at this point.